Hello everyone, I am Ankur Dey and I am here to present our project titled The Uses of Machine Learning Algorithms to Forecast the Player's Performance. This work was done as a team with Shraosi Dawn and Soumit Roy as a part of the course Statistical Methods in Artificial Intelligence, popularly known as SMAI, at IIIT Hyderabad. Before I begin, I would like to sincerely thank Professor C.V. Jawahar for offering us this opportunity and inspiring us through this course. I also wish to extend our heartfelt thanks to our TAs, Himanshu Singh and Devika Vej, for their constant support and valuable feedback throughout the project. Cricket, being the second most watched global sports, is evolving rapidly with technology. With tools like speedometer and ball tracking already in use, the next step is leveraging data analytics and machine learning to analyze performance and support strategic decisions. Our project explores how KNN, name-based, and SVM and MLP can be applied to real-world cricket data to forecast player performance, especially targeting the 2026 ICC Men's T20 World Cup. Okay. The core idea of our study is the question: how can machine learning aid in player evaluation and strategy planning in cricket? We worked with both T20 International and Indian domestic league data sets, aiming to build models that help selectors and analysts make decisions driven by data. Our primary focus is to build a versatile and resilient team of 11 players capable of performing under all possible match conditions, whether favorable or challenging, with the ultimate goal of consistently competing with the highest level and winning the trophy. By using machine learning to forecast player performance, we aim to support strategic team building for high stakes tournament like 2026 ICC Men's T20 World Cup. Now, this is a schematic diagram. Here you can see a classification framework. It takes player statistics and assigns them to categories like batsman, bowler, fielder, or wicketkeeper, and ultimately leading to predicting our team. To build reliable data set, we extracted statistics from ESPN Cricinfo, one of the most comprehensive big data source available. We noticed a lot of missing values in the raw data, particularly zeros where actual performance data was likely unavailable. To address this, we use class-wise average imputation, which help maintain data integrity and ensure consistent and meaningful input for our models. Now, in terms of what we extract, we defined specific attributes for each category of player: batsman, bowler, wicketkeeper, and fielders. For batsman, we take attributes such as number of innings, batting average, strike rate, and boundary percentage. Similarly, for bowling attribute, we have taken number of innings, bowling average, bowling strike rate, overs, run conceded, and medal numbers. And fielding and wicketkeeper attributes are number of innings, catches taken, catches by wicketkeeper, and stumping. So based on this, we classified batsmen into top order, middle order, and lower order roles using well-defined threshold as mentioned here. These are the threshold. Similarly, for bowler, we have actually classified into good bowler or bad bowler. The thresholds are mentioned here. And for fielder wicket keeping attribute, this is something different. We consider for wicketkeeper number of innings, catches by the wicketkeeper, and stumping. And for fielders, we have used catching performances and match appearance. Uh, so to further define our selection process, we introduce a metric that is there in methodology that is called consistency metric. This is a weighted formula that combines several of the above attribute into a single score that ranks players within their role, allowing us to prioritize those who perform reliably across matches. Well, I have already mentioned consistency metric. In our project, we introduce a metric like this to rank players within their respective roles based on sustained performance. This metric combined multiple attributes like average strike rate, innings, and dismissal into a single weighted score. For batsmen, it emphasizes scoring consistency, match experience, and ability to convert starts into big scores. For bowling, it considers workload, wicket-taking ability, and efficiency across matches. For wicket keepers and fielder, it reflects active participation in dismissals and field presence. Unlike raw stats, this metric penalizes inconsistency and rewards players perform reliably across different conditions. It helped us identify top performer from within each player or within each class after classification was complete. Ultimately, the consistency metric played a central role in selecting a balanced, dependable, and competitive playing 11. The next slide, we have the data visualization. Here you can see that we have plotted various attributes with the number of players. For histogram for batsman, histogram for bowler, histogram for fielding and wicket keeping data has been shown in this particular slide. Okay, so after this data visualization, we have with us the learning models. Data classification is a process of labeling data points, as I have previously mentioned. And by assigning them to specific categories or classes using predefined rules, threshold or trained models, we have actually chosen k-nearest neighbors, that is the KNN model, naive-Bayes model, and support vector machines and multi-layer perceptron method to perform prediction tasks. So the thing is that in the next slide, you will see the results on T20 I data. Comparison of accuracy, precision, recall, and F1 score of different learning model has been shown in this particular diagram. And we observe from our analysis that MLP perform best in the case of batsman data, while KNN model perform best in case of bowler data, which is based upon all metrics. And in case of fielder or wicket keeper data, as you can see, all the model perform well. Only the naive-Bayes model is actually give slight lower value. Okay, So next, what we have actually, next we have taken Indian domestic league data. To validate our approach, we applied the same models to the Indian domestic league data. We observed significant variation in model performance. Okay, so next, what we have is depending on the defined attribute consistency, we found different batsmen for different orders and plotted the histogram of the best performer of Team India in a histogram. The same is true for bowler and fielders. The formula for consistency are followed as it has been chosen, it has been given here. We see comparison plots for batsman, top two batsman, top two bowler, and top two fielder and wicketkeeper in each class. Next, we take Indian Domestic League. To validate our approach, we applied the same model to this particular data. We observed significant variation in model performance, largely due to home ground advantage and other localized factors, making international data more reliable. And you can see from here that there are outcome of Indian Domestic League uh, and the outcome of T20 data set for batsmen. You can see that the top two consistency batsman is actually top order is Rohit Sharma and Virat Kohli, and in IPL it is Rohit Sharma, S.K. Raina, and R.K. Singh. It has been shown here. Similarly, we have done, and we see that uh, P. Kumar, Kuldeep Yadav, and Hardik Pandya, the Ashish Nehara, if you see, is actually considered to be bad player for Indian domestic league data. But for internationally, you will find that Kuldeep Yadav is a very good player, means top one, top bowler, and Ashish Nehra is also top bowler. And Bhuvneshwar Kumar and Hardik Pandya is the bat bowler in this case. So this is the change that we got, and it is quite interesting for us. Conclude, our project demonstrates the potential of machine learning in enhancing player evaluation and team selection in cricket. By extracting player statistics, applying classification algorithms, and introducing a consistency metric, we build a system that can assist selector in making objective data-driven decisions. We found that MLP performed best overall for classification, especially for batsmen and fielder, while KNN worked best for bowlers. The introduction of consistency metric allowed us to go beyond classification and identify top performing reliable players within each role. One of the most important insights from our work was the discrepancy between international and domestic data. Domestic performance often showed inflated consistency, likely due to home ground advantages. This led us to conclude that international performance metrics are more reliable and should be prioritized in national team selection. Our approach is scalable and adaptable and can be applied to other formats like ODIs or test matches with minimum modification. Ultimately, the project provides a framework for combining statistical analysis with machine learning to make cricket strategy more intelligent, consistent, and fair. Future research direction. We can do injury prediction and workload management. It can help identify when a pair needs rest or is at risk of injury. We can also build a interpretable models that justify player selection and tactical recommendation. Application in fantasy sports for real-time team recommendations and deeper fan engagement through predictive insights. So these are our references from where we have got the ideas. So I have already previously acknowledged Professor C.V. Jawahar and also the TAs Himanshu and Devika Bej. Thank you very much. Thank you all.